Okay, in question 3 part A, we're talking about functions. And if you want to study the material in this question, go to functions 4 on the website and explore everything you need to know about composite functions. In this question, we're told that f of x is 6x minus 5. And we're told that g of x is x plus 5 divided by 6. We need to investigate if f of g of x is equal to g of f of x. So I've done the first one here, f of g of x. If I need to get f of something, like imagine what it would mean if I was asked to get f of 2. That means everywhere there's an x in the function for f, I would sub in a 2. So I've been asked to get f of g of x. Ultimately, I'm subbing into the function for f. But g of x is x plus 5 over 6. So if I'm looking for f of g of x, that means I'm looking for f of x plus 5 over 6. So I'm looking at the function f, which is 6 times x minus 5. But instead of an x, I'm going to sub in x plus 5 over 6. And the function 6x minus 5 is going to become 6 times x plus 5 over 6 minus 5. This one works out nice enough now because there's a 6 on the bottom and a 6 on the top. Cancel each other out and I get x plus 5 minus 5. Plus 5 minus 5 cancel out and I'm simply left with x. So simplified fully, f of g of x is just x. What I've done here is I've worked out g of f of x. If I'm looking for g of something, that means ultimately I'm using the function x plus 5 over 6. And in this case, I want g of f of x. And I know that f of x is 6x minus 5. So I'm looking for g of 6x minus 5. So I need to rewrite the function for g, but instead of an x, I need to sub in what's in the brackets, 6x minus 5. When you sub in, you get 6x minus 5, and then you still have your plus 5, and it's all over 6. And the plus 5 and minus 5 cancel out. You end up with 6x over 6, so you end up with x. So we've worked out that f of g of x is equal to x, and that g of f of x is equal to x. So we can conclude that in fact, yes, f of g of x is equal to g of f of x. Okay, in question 3, B part 1, we're told that y is equal to 5x squared. And we're asked to show that this can be manipulated and written in the form that log y to the base 5 is equal to a plus b log x to the base 5. We need to find a value for a and a value for b. In order to explore the material for this content, I want you to go to indices and logs 2 and 3 from the website. Now, let's explore how we can do this. Our starting point is y equals 5x squared. And I know that at the end, I want to end up with a log y to the base 5 on the left-hand side. So if y is equal to 5x squared, I'm going to introduce log to the base 5 on each side. If y equals 5x squared, I can say that log y to the base 5 is equal to log of 5x squared to the base 5. The reason that I'm doing that is because I can see that I want to end up with log to the base 5. So I'm going to introduce it. And the left-hand side is as it needs to be in the answer. The right-hand side, we need to manipulate it around. So let's ignore that for the moment. We'll get back to it at the end. So you should go to page 21 in your maths tables. And on page 21 in your maths tables, there's a number of rules of logs that we can use. The first rule of logs tells me that if I've log of x multiplied by y, I can split it up, so it's log x plus log y. So on the right hand side here, I've log of 5 multiplied by x squared. Based on that first rule of logs, I can split this up into log 5 to the base 5 plus the log of x squared to the base 5. So instead of multiplying the 5 by the x squared, I can split it up and add the two different logs together. Now, you should know off the top of your head that log 5 to the base 5 is actually just 1. If you have the same number there and there, then the value is just 1. Now look at the third rule of logs on page 21 in your maths tables. It tells me that if I've log of something to a power, I can just bring the power in front. So log of x to the power of 2 will become 2 log x to the base 5. So I've simplified the right hand side fully, and you should notice that it's now in the format that I was asked for. I ended up with log y to the base 5 is equal to 1 plus 2 log x to the base 5. So I can conclude that A is equal to 1 and that B is equal to 2. And that'll get me the full marks for B part 1. In B part 2, we're asked to hence or otherwise find the values of y for which log y to the base 5 is equal to 2 plus the log of 126 over 25x minus 1. Now this equation is almost exactly the same as the types of questions we were doing in indices and logs 2 and 3. So if you're struggling, go back to those tutorials and it should clear it up for you. What I need to do first of all is essentially I want to try and eliminate my logs. I have a log to the base 5 on the left and a log to the base 5 here. The immediate complication is that I also have a 2. Like there are rules in my maths tables that allow me to group or to add or multiply log to the base 5 if you've got the same base. But there's no rules there that allow me to manipulate a log to the base 5 and a 2. They're just different genres basically. They're just not like terms. There's nothing I can do there. So if you go to your maths tables, look on the top right hand corner. We're going to use that rule on the top right hand corner. If this is a log to the base 5 and this is a log to the base 5, I want to turn this term into a log to the base 5. Instead of a 2, I want to have the log of something. Let's call it for the moment, I don't know, w. Let's call it for the moment w. I want to have log of something to the base 5 instead of the 2. Whatever I substitute in there, it has to be equal to 2. And if you look at the rule on the top right hand corner, page 21 in my maths tables, it tells me that the base to the power of the answer gives me whatever w is. 5 to the power of 2, 5 squared is 25. So I can deduce that instead of a 2, I could sub in log of 25 to the base 5. And I'm happy out with that, because then obviously you just substitute it in and I'll have all log to the base 5s. So what I'm going to do is just rewrite my equation. Instead of a 2, I'm going to sub in a log 25 to the base 5. Obviously I do nothing with the left hand side, but on the right hand side I have a log of 25 to the base 5, and then the second term is going to stay the exact same. Now, my goal here is to eliminate the logs. Once I have a log to the base 5 on the left and one log to the base 5 on the right, I'll be able to eliminate the logs. So the problem at the moment is the fact that there are two separate terms on the left hand side. If you look at the first rule of logs, the one we used in B part 1, instead of adding these two logs together, I can write them as one log. If I multiply the 25 by the thing in the brackets here, I can amalgamate these into one log and write it as 25 times 126 over 25x minus 1. And I get that from that first rule of logs in the top middle column of page 21 in the log tables. And here the left hand side is just log y to the base 5. I have one log to the base 5 on the left, one log to the base 5 on the right, so I can eliminate the log to the base 5s, and I'm simply left with y, and 25 times 126x over 25 is 126x. 25 times minus 1 is minus 25. I'm starting to get into more straightforward, more recognizable algebra here. In B part 1, we were told that y is equal to 5x squared. So at this point, I'm going to substitute that in instead of the y, because otherwise I've got one equation and two unknowns, so it's impossible for me to find for me to solve this. But if I sub in 5x squared instead of y, then I'll be happy out. So instead of the y, I sub in a 5x squared. And I notice that I have an x squared, I have an x, and I have a number. So I obviously have a quadratic equation. I'm going to move everything to the left-hand side, and I'll get 5x squared minus 126x plus 25 equals 0. Now all I need to do is factorize this quadratic. It's handy enough because you should notice that 5x times 25 is actually 125. So now it doesn't matter whatever way you're used to factorizing these, but you should end up with 5x minus 1 times x minus 25 equals 0. You're going to let each factor equal to 0, so I can let 5x minus 1 equal to 0, so 5x equals 1, so x must be equal to 1/5. Or you let x minus 25 equal to 0, so you get x equals 25. But at this stage you should notice the question didn't ask me to find x. The question asked me to find y. So I am going to revert back to what I had at the start of part B. Instead of x, I'm going to sub in 1/5 and get the corresponding y value. And then instead of x, I'm going to sub in 25 and get the corresponding y value. So I know that y is equal to 5x squared. In this scenario where x is 1/5, then y also, by coincidence, works out as 1/5 as well. In this scenario where x is 25, y works out as 3,125. So there are your two answers for B part 2 here.